Hello, everyone. This is probably the last chemistry video I'm gonna make of this year, which is kind of crazy. So let's go out with something kind of boring. This is gonna be about the pH scale. So, what the pH scale is it measures the concentration of the H3O plus or H plus, the positive, the hydrogen, or it's the acidity of a solution. pH scale ranges from 0.0 to 14.0, and how it works normally goes up and down, but I'm going to draw it this way. So 7 is your middle, and the farther this way you go, the more acidic something is, and the farther this way you go, the more basic. So 1 is something very acidic, 13 is something very basic, 1 is more acidic than 4, just like 13 is more basic than 9. 7, this would be water, just like pure water for reference. So that's the pH scale. And the pH scale is a logarithmic function. And it takes those self-ionization of water calculations, and it basically makes it a whole number and something the average person can understand. So there's a bunch of formulas to use to do this. So first we have pH equals the negative log of the molarity of H3O plus. So this is when we know this that I've badly underlined, and you take the negative log because remember this will have a negative exponent. So that way you get rid of the negative and so that's how you get pH. Say you want to find the molarity, you know the pH. You would take the antilog of the negative pH, or you could say it's 10 to the negative, whatever your pH is. That will get you your concentration. So now there's also a thing called pOH, and that measures how basic a solution is. So it's the same scale, except it's inversed. So now the lower the number, the more basic, the higher the number, more acidic. So pOH again is just the negative log, but of the OH this time. I would say just stick with pH, work things in that, and then convert, don't try. That doesn't make sense. I'll explain a little bit in a minute, but that's what pOH is. And then if you're looking for the concentration of OH, that would again be just 10 to the negative pOH of whatever you're finding. And then the last little formula to know is that pH plus pOH equals 14. Since they're the opposite, because for however much acid you have, acid particles, you're gonna need the much base particles to make 14. Okay, let's do an example, because that probably will make way more sense. So say we know that the molarity of H3O is 6.2555 times 10 to the negative 5. Okay, and we want to find the pH, the pOH, the molarity of hydronium, and the molarity of hydroxide. Well, we know the molarity of hydronium, so we need to find the other three. Now, there's a couple ways to do this. To find the hydroxide, you can just use that formula from the last video and do it that way where you divide, and then once you get that, but let's use the new formula. So say we want to find the pH. The pH equals the negative log of our hydronium. 6.2555 times 10 to the negative fifth. You stick that in the calculator and round to 5 sig figs, you get 4.2037. No units because it's pH. POH won't have units. H3O plus and OH minus will have this M unit. Okay, so we have the pH. So now we want to find the POH. So that's just going to equal 14 minus what we just found to give us 9.7963, because pH plus POH equals 14. So that's, we now have POH. And then we need the molarity of the hydroxide ion. So that is just going to be 10 to the negative, because we need to do the opposite of logging it. So 10 to the negative of the POH, and that'll give us 1.59, woo, 1.598 times 10 to the negative 10, the molarity. Now, if you start by finding this, and then you take the, and then you do the pH, and so say you found this first and then did the POH, your sig figs will be different. That's fine. You just, as long as you show your work, your teacher should know what you did. So that's how you can kind of solve for pH using those 5 equations we have. So basically just, if you know the ion and you're trying to find the P blank, you're going to negative log. If you know your pH or POH, you're going to take 10 to the negative of your ion. Okay. And I think that is, oh, one more thing. So we're working with logs. The pH scale is logarithmic. So that means each jump is 10 times the one before. So if we go back to our scale, say we're at 2 and we go to 3, it's a 10 times as strong, going this way, 10 times as strong when you go from 3 to 2. So say you're going from 4 to 2, that would be 100 times as strong, because we're working with log base 10. So that's just something to point out, to keep in mind. That's why pH balance is so important, because when you just jump one value, you're really jumping by 10 times as much of that value. So that is it for pH. And probably chemistry videos in general. Let me know if you have any questions or need more clarification. I'm happy to help. And yeah, have a great rest of the school year and a nice summer. Thank you so much.